welcome. So the topic we'll be discussing in today's lecture is basically we will discuss first something called as binary tree traversals. Okay, which means that what are the different ways of traversing or traveling through the binary tree. That we'll be discussing first, and then we'll be discussing how the various traversal techniques can be implemented in C. Right, and also I'll show you how to implement a binary tree in C language. Before traversing, of course, you should have the tree should be implemented, right? Okay. So, but the order will be like this. First, we'll be theoretically discussing what are the various ways of binary tree traversals, and then straight away we'll go for implementation of tree traversals, assuming that the tree is already implemented. Okay. And then I will be showing you the code for how to implement a tree data structure. Fine. This is the order. Okay. Fine. So basically there are 6 ways of traversing through a binary tree. Basically there are 6 ways to traverse a binary tree, but in general we use only 3 ways of traversing. These 3 ways are commonly referred as in-order traversal, post-order traversal, and pre-order traversal. Okay. So what does these what is in-order traversal, what is post-order traversal, what is pre-order traversal? Before getting into that detail, what are the 3 ways of traversing a binary tree that we will first try to understand. Okay. So here we are using 3 terms L, V, and R. V represents a particular node. Okay. V represents a particular node. V means visit a node. V means V stands for visit. Okay, visit what in a binary tree what you have only nodes. Okay, visit that particular node. That is what the V stands. L represents visit the left child of that node. Whatever the node we are talking about, that node is referred as V. Okay, visit that particular node. So V may refer to a node X. Okay, V refers. Let us assume that V refers to the node X. L refers the left child of node X. Okay, L says that visit the left child of node X. V says just visit node X. And R means visit the right child of node X. Okay, so these are the 3 terminologies which we are going to use. L, V, and R. So L means visit the left child of a particular node. V means visit exactly that particular node, and R means visit the right child of that particular node. Okay. So with this L, V, R, if you see what are the possibilities of visiting these 6 are the possibilities. Okay, LVR or LRV, okay, or VLR or VRL or RVL or RLV. Okay. So what is meant by LVR? LVR means before visiting a particular node, visit its left child. Okay. Then visit that node. Then visit its right child. If you follow that order, that is called as LVR. Okay. LRV means before visiting a particular node, visit its left child, then visit its right child, then visit that particular node. That is called as LRV. Okay. VLR means first visit that particular node, whichever the node you want to visit, X. Then visit its left child. Okay. Then visit its right child. Okay. I mean, we will be finally visiting all the nodes, but currently you will start with one node, right? First, for example, we start with root node or some other node. I mean, in the traversing process, you may be at one point of time, you may be in a given node. So that node we are calling as X. Okay. So VLR means first visit that node, then go to its child, left child, and then go to its right child. Okay. VRL means first visit that particular node X, then visit its right child, and then visit its left child. Okay. RVL means for a given node X, first visit its right child, then visit that particular node, then visit its left child. Okay. RLV means first visit the right child of that particular node of node X, then visit the left child of that particular node X, then visit that particular node, that is the node X. Okay, fine. But generally, normally when you traverse a tree, first we visit the left child, left child, okay, and then only we will visit the right child. Okay, so the order may differ. Okay, first you may visit the, I mean always it is from after visiting left only we visit right. Okay, so it can be either you see this LVR here also. What happens after visiting left only you are visiting right. You take this LRV here also after visiting left only you are visiting right. Okay. Okay. So similarly, if you take VLR, here also after visiting left, only you are visiting right. Okay. V may come anywhere. That visiting that node may come anywhere. It may come in between left and right, or it may come before left and right, or it may come after left and right. Okay. But generally we first visit the left child and we may and after that the right child. Okay, we the current node may be visited either before visiting the left child or after visiting the left child or after visiting the right child. This that depends. Okay, but nowhere we follow this approach. We will not follow this approach of first visiting the right and then coming to the left. So all these three cases, if you see, first we visit the right child and then the left child. Here also first right child and then the left child. Here also first the right child and then the left child. So these three cases we are ruling out. We are not going to use in computer science for tree traversals. This is normally not used. Okay. So we will be taking only these three cases. Okay. These three cases, right? So these three cases are called as with different terminologies. Okay, what are they? They are called as in order, post order, and pre order. If you visit, if you visit that particular node first, if you visit whatever whichever the node you want to visit, the X node first, and then go to the left child, and then if you go to the right child, then that is called as pre order traversal. Okay. If you visit the given node last, first you visit the left child, then visit the right child, and then the given node, then that order of traversal is called as post order. Okay, right? And the other thing, first you visit the left child, then the given node, and then if you visit the right child, and this order of traversal is called as in order traversal. Okay, so these are the three ways of traversing a binary tree. Okay, fine. So let us take an example. Assume this is a binary tree. Okay, this is a binary tree, right? So here you can see, so these are the given nodes, right? The root node contains plus and it has a left child star and a right child E. E does not have any children. So basically E is a leaf node. Okay, it's a null. So this null is shown like this here. Okay. Similarly, the node star has two children. Again, it's another star and D. Okay. And this star has two children. Left child is slash and right child is C. And this slash has two children A and B. Okay. So A, B, C, D, E, all these are leaf nodes. Okay. Now let us see how this tree will be traversed in order traversal first. So in order means what? Okay, in order means or first we will start with pre-order. Okay, first we will start with yeah. Okay, first we'll fine. First we'll start with pre-order. Okay, first we'll start with pre-order. So pre-order means what? Pre-order means first you have to visit the root node. Okay, so first you have to visit that given node. Okay, that is the root. Okay, then its left child and then its right child. Okay, so instead of V, for our convenience, let us call it as root. Okay, first visit the root node RT. Okay, then visit its left child and then visit its right child. So that type of traversal is called as pre-order traversal. Okay, so start from the root node. I mean, start from the root node. Okay, so here root in the sense, what I mean in the sense, for every subtree there will be a root node. If you take this subtree, for this subtree, this star is the root node. Okay, are you getting? So the root, of course, this is the root of the tree, but for every subtree there will be a root node. Okay, in that context we are referring. Fine. Okay, let us follow. So it means that first visit the root node, then the left child and the right child. Okay, fine. So you see, first it is plus. So when you start, first node is plus. Is it a root node of some subtree or not? Is it a root node of some subtree or not? Yes. Then visit it. Visit means it is already done. Display that. Okay. Then go to the left. What is the order? After visiting root, go to the left. Then go to the left. If you go to the left, you will get star. Again, if you see star, is it a root node of some subtree or not? Yes. This star is a root node of this particular subtree. If you take this subtree, then for that subtree star is the root node. Okay. So for this subtree star is the root node. So in that context, it is also a root node. It is also a root node. So again visit that, because first you have to visit the root. Okay, visit that. Again move left. Again you get another star. Okay. Again, is this is the root of some tree? Yes, this is the root of this subtree. So visit that. So display star. Okay. Again move left, because after visiting root your duty is to go left. Okay. Again when you go left, because that is what pre-order traversal says. After visiting root, go left and then right. Okay. But as long as it is a root, you keep going left. That is the meaning. Okay. So then when you come here, slash. So is it a root of some subtree? Yes, this is a root of some subtree. This. Okay. So print slash. Okay. Fine. So again you go left, because after this is a root, then go left. So if you go left, you got A. You got A. So is it a root of some subtree? No, it is not a root node. So this is the left. This is the left of this particular node slash. Okay. So now you visit this left node. Okay. So left node is A. Okay. Left of this slash is A. Its right is already, sorry, its root is already visited. So after left, what should be visited? Its right node. What is its right node? B. So B. So B comes. Right? Okay. Now this entire thing is what? It's the left child of this particular root node. Okay. If you consider this subtree, for this subtree, this is the root node, and for this root node, this entire thing is the left child. Okay. This entire thing is already displayed. Right? The root is also already displayed. So it means you already visited the root. The star is already visited, which is the root node of this subtree. Its left child also already visited. So what is its right? So root is visited, its left child is visited. After that, what should be visited? Its right child. So what is its right child? Its right child is nothing but C. Its right child is nothing but C. So visit C. Okay, fine. So visit C. Now if you see, this entire thing is nothing but the left child of this particular subtree. Okay, this particular subtree. So again, if you see this particular subtree's root star is already visited, this entire left child is also already, or left subtree is also visited. So what is left is its right subtree. What is its right child? D. Okay. So now go to its right child. So what is the right child? Its right child is D. So visit that. Right? So now again, if you see this particular thing, this below that, whatever it may be, so this entire subtree is the left subtree of this main root node. Okay. So already we have visited the root node, and also this entire subtree is visited. So what is left is its right child. Okay, or its right child is E. Okay, so visit that, right? So this type of traversal is called as pre-order traversal. This type of traversal is called as pre-order traversal. So here pre in the sense pre represents what should be visited first. I mean route should be visited where? Route should be visited first, so that we are calling it as pre-order. Pre, before visiting anything else, first visit route. Okay. So this is the output. Okay, if you visit this in pre-order fashion, you will get like this. Okay, right? For example, say here uh, E, after E there is some node. Say E, F and G. In that case, what will be the output? Of course, after visiting plus, you will come back to E. But yes, E is a root node, so you have to display that. But now, after visiting root, you have to go to its left. What is its left? F. Okay, and what is its then go to its right. What is its right? G. Okay, like that it will come, right? So this type of traversal is called as pre-order traversal, right? Okay, fine. Next we shall see post-order traversal. What is post-order traversal? In the sense, so this is pre-order. Post-order is what post-order says in the sense. Post-order means root should be visited at last. Root should be visited at last. First visit the left child, then the right child, okay, and then the root. Okay, first visit the left child and then the right child and then the root. Okay, so let us start with the root of the tree. It is plus. It is plus. Is it a left child of something? No, it's not a left child. Okay, so go left. Go left. Okay, is it a left child of something? It is a left child of something, but more than that, is it a root of something? It is a left child of plus. Okay, that is true. But is it a root of something else? Yes. It is a root of this big subtree. Okay. So don't visit it. First you have to visit the left child only. Then only root. Okay. So again go left. Okay. So again star. Again star is coming. Another node. Is it a root of some node? Some tree? Yes, it's a root of this particular subtree. So don't visit. Go left. Slash. Is it a root of some subtree? Yes, this is the root of this particular small subtree. So don't visit, go left. Yay. Is it a root of any subtree? No, it's not a root, it's a left child of some node. So visit that. So what is that? Yay. Yay. Okay. So now we have visited left child. Then go to the right child. After visiting left, you should visit the right child. What is the right child of this node? B. So then visit B. Okay. Then visit the root. Left, right and then root. So what is the root? Slash. Okay. Right. Now if you see, this entire thing is nothing but the left part of left subtree of this root node. So its entire left is visited already. Okay. So with respect to this, considering this as the root of some subtree, its entire left is already visited. So after visiting left, what should be visited? Right. So what is its right? C. Okay. What is its right? C. But is it a root of something? Again, you should check. It's not a root, so you can visit. If it is a root of something, say C is a root of something, then you have to go to the left. In that way, you have to go. Okay, but it is not a root, so visit. So what you will get here? C. Okay. Now star's left subtree is visited. Its right subtree or child is also visited. Now visit the root. What is the root? Star. Root. Okay. Now if you see similarly, this entire thing is a left subtree of this particular uh, subtree for which this is the root. Okay. So again all these left part is visited. So go to its right. D. Is it a root of something? No. So visit. Okay. So visit. Its left is already visited, its right is visited, now visit the root. What is its root? Star. Okay. Now see this entire thing. This is a now see this entire thing. This entire thing is the left child of this super root node. Okay. So this entire left child is already visited. So now visit the right child. What is the right child? E. Is it a root of some other subtree? No. So visit it. E. Okay. Now for this root node, that is the main root node, its entire left subtree is visited, its right subtree or right child is also visited. So now visit the root node. Okay. So plus will come here. Right. So A, B slash C star D star E plus. So this is the order of visiting when you follow post order traversal. Okay. Fine. Now let us see what is meant by in order traversal. So in order traversal, what it says in the sense, in order traversal, first left should be visited, then root and then right. So such traversal is called as in order traversal. First visit the left child, then visit the root node. First visit the left child, then visit the root node, then visit the right child. So this way of traversing is called as in order traverse. Okay. So again start from the root node. So start from the root node. Is it a left child of something? No. So go left. Go left. Is it a left child of something? Yes, it's a left child of something. But it is also a root. But it is also a root. So go left. Okay. Is it a left child of something? Yes, it's a left child, but still it is a root. So it should not be a root. So go left. Again, if this is a left child of something, yes, but still it's a root. So go left. Is it a left child of something? Yes, it's a left child of slash. Is it a root node? No, it's not a root node. Okay, so visit that. Visit A first. Okay. After visiting left child, what should be visited? Root. So what is the root of A? Root of A is slash. So visit that. After that, visit right child. So what is the right child of slash B? Okay. So now if you see, this entire part is a left child of star. So this entire left child is already visited. After that, as of in order traversal, what should be visited? Star should be visited. Okay. So I'll write here. So A slash B already we have visited. Okay. This is slash. Okay. Sorry. This is slash A slash B already visited. So this entire left part is already visited. Next what should be visited? Root. So star. Okay. So then what should be visited? It's right child. So after visiting this, come to the right child. It is C. Okay. Now this entire thing is the left subtree of this. Okay. So this left already visited. So its root is star. So because after visiting left, now we should visit root. Okay. So star and its right child is D. Its right child, is it a root of something? You have to check. It's not a root, so that we are visiting. If this is the root, again you should go to left. Okay. So visit D. Okay. Again, if you see, this entire thing is a left child of some other node. Okay. Some other subtree. I mean this node. Okay. So this entire left subtree is visited. So now we see the root. That's the main root. So plus. Then we see the right child E. But again, is it a root? It's not a root. So visit. Okay. So this is what you will get if you traverse in order fashion. A slash B star C star D plus E. Okay. So these are the three commonly used what you call tree traversal techniques. Okay. There is another one traversal technique which is called as level order traversal. Which is called as level order traversal. As the name suggests, level means visit all the nodes in a particular level, starting from left to right. Okay. Visit all the nodes in a particular level in the left to right order. Okay. Starting from the level 1. Starting from level 1, visit all nodes from left to right. Once level 1 is completed, go to level 2. Visit all the nodes in left to right. Okay. Once level 2 is completed, go to level 3. Visit all the nodes from left to right. So on and so forth until you reach the nth level. After reaching level n, again visit all nodes from left to right. Okay, so this style of traversing is called as level order traversal. So if you level order traverse this tree, what you will get? First level 1, there is only one node, plus this is level 2. Okay, it's not 3, sorry, it's 2. Level 2, so star and E visit from left to right. So star and E. Level 3, star and D, so visit star and D. Level 4, slash and C, visit level 5, A and B. That's it. So this type of traversal is called as level order traversal. Okay, slash star E star D slash C and B. Okay, fine. So you can take different graphs and you can try like what is the pre-order traversal, what is the post-order traversal, and what is the level order traversal, what is in-order traversal, all these things. Okay. Previously, if you remember, we have discussed what you call infix, postfix, and infix and postfix expression. Okay. So uh, yeah. So when you perform in-order traversal, what you get is called as infix expression. Okay. And when you perform post-order traversal, what you get is called as postfix expression. Okay, postfix expression. When you perform post-order traversal, what you get is called as postfix expression. Okay. So here in-order traversal you got like this, right? What you got? A slash B star C star D. So here there are three operators, slash, star and star. All these has equal priority. Okay. So how it will be executed? It will execute from left to right. So first, so a bracket, an implicit bracket will be added so that the compiler will know what should be done first. So first it will do A slash B because it will go from left to right. Okay, then it will do the result of A slash B star C. Okay, then it will do the result of A slash B star D. The result of A slash B star C, that will be multiplied with D. Okay, then this entire thing will be multiplied with E. Are you getting? So post order, if you remember how you did, starting from the innermost bracket, this slash will replace this bracket, this star will replace this bracket, this star will replace this bracket, this plus will replace this bracket. So what you will get? AB slash, okay, C star D star E plus. That's what you get. Are you getting? Okay. But what is pre-order? If you pre-order, prefix we have not discussed. In prefix, what happens in the sense, it is just opposite to postfix. In for postfix, this operator here also you should start with the innermost bracket, but instead of replacing the right parenthesis, nearest right parenthesis, replace the nearest left parenthesis. So this star will this slash will replace this parenthesis. Okay, this star will replace this parenthesis. Okay, this star will replace this parenthesis, and this plus will replace this parenthesis. Okay, so first what you will get is this plus. Okay, so first you will get this plus, right? And then this parenthesis is replaced by star. So then you will get star. Then the third parenthesis is replaced by this star. So again you will get star. Okay. And the fourth parenthesis will be replaced by slash. So then you will get slash. Okay. Then just all the operands A, B, C, D, E. So A, B, C, D, E. So this type of representation is called as prefix representation. So as a result of pre-order, what you get is called as prefix expression. Okay, right? So this will happen only when, in the sense, this will happen only if an arithmetic expression is represented through a binary tree. Okay, here you can see the heading. When the arithmetic expression is represented through a binary tree, then if you traverse in order, you will get the actual expression. If you traverse in pre-order, you will get the prefix of that particular expression. If you travel in post order, you will get the postfix of that particular expression. Are you getting? So a tree always need not be an arithmetic expression, it may be something else also. So what I mean is you can take any tree and you can traverse in, you try manually with pen and paper, traversing in order, pre-order, post-order, all these things, so that you'll get familiar with these things, right? For example, you can take this tree and you can traverse in pre-order or in order or whatever it may be, right? Okay. For example, I can say you, say if you traverse this tree in order, then how will you do? So in order means left, root, right. Okay. So so first you have to visit the leftmost child. So start with root. Is it a left child of something? No. So go left. Is it a left of something? Yes. But is it a root of something? Yes. So it should not be a root. Go left. Is it a left of something? Yes. But is it a root of also something? Yes. So go left, left. So H. Is it a left of something? Yes. Is it a root of anything? No. So we visit that. So H. First in order means first H. Then after that what should be visited? Root. So what is the root of H? D. So visit D. Then right. What is its right child? I. So then visit I. Okay. Now the entire left of node B is visited. So its left is already done. So after visiting its left, what should be visited? Root. Its root. So the root of this entire subtree is what? B. So visit that B. Okay. So now its left is visited, root is visited, then what should be visited? Its right. That is E. Okay. Now this entire thing is the left of what? A. So this entire thing is already visited. So after that what should be visited? Its root. So what is its root? A. Okay. Then go to its right child, C. But is it a root node? Yes, it's a root node. If it is a root node, then go to its left, F. Okay, but now is F is a left child of something? Yes. But is it a root node? No. So visit F first. Okay, visit F. Then go to its root. What is the root of F? C. So visit C. Then go to right. What is the right child of C? G. Okay. So that's it. So this is the in-order traversal of this particular tree. Like that, for this tree, you can perform pre-order and post-order, or you can take some typical tree and right. So you can take it as a homework. For this particular tree, you perform all in-order, pre-order, and post-order, right? Okay. Even this tree also you can traverse in order, pre-order, and post-order. Let us see what comes. Okay. You can take this also, traverse in order, pre-order, post-order, right? So whatever the trees we have seen so far, you can take and you can try traveling through in order, pre-order, and post-order form, right? Now let us see the implementation, how to traverse a tree in various, we'll be discussing these three formats, in order, pre-order, and post-order, okay? So this is the logic for traversing a tree in order. Okay, void. So there is a, we assume that already the tree is implemented. Okay, so void in order. There is a function in order. Okay, which receives a pointer to the root node. Which receives a pointer to the root node. So tree pointer is nothing but a pointer to a node. So the tree pointer is nothing but what? It is a it is a it is a it is a pointer. It's a user defined data type basically, which is a whatever the data for variable you create for tree pointer, it is a pointer to node. Okay. So basically this pointer now points to the root node. So first we check if ptr. If ptr means what? Ptr means, so this statement is equal to checking whether if ptr is not equal to null. This will return. So actually here we are checking whether ptr is not equal to null, right? If it is not equal to null, then this for will execute. Otherwise this will not execute. Okay. So if it is not equal to null, what you are doing, in order, again, see, actually this is a recursive function. Actually this is a recursive function. Here again what you are doing is this is a in order traversal. So in order traversal means what is the order? First what should be visited? First visit the left child, then root, okay, then visit the right child. Okay. So what we are doing is we are saying that you for this particular you again we are calling the function in order, the same function in order recursively we are calling, and for this parameter what you are passing is you are passing the its left child. This node is pointing to the root node, right? So root node's left child, whatever that you are passing. Okay, are you getting? So the left child is now passed here. Again, it will check whether it is null or not. If it is not null, its left will be passed. Its left will be passed. Okay. So if you see in order traversal, we go and finally we reach the leftmost node, which does not have a child node, right? So that is what this exactly do. Finally, you reach that leftmost node which does not have a child. Okay. Once you reach that leftmost node which does not have a child, right? Say at one point you reach the node A, which does not have any child. So now PTR refers to node A. PTR refers to node A. Okay. Again you say is PTR is null? No. PTR is pointing to node A. PTR is pointing to node A. At this point, what are you doing is again you are saying in order PTR of left child. But does A has a left child? No. So left of A is nothing but null. Okay, so again you are calling in order, but this time you are passing null. Okay, and after coming here you are checking if PTR, if PTR means basically you are checking whether PTR is not equal to null. Actually now PTR is equal to null, right? If PTR is equal to null, then what will happen? Actually the control will return. So when the control returns, the control will come here, right? Right? So actually here a lot of stack is involved. So let us try to understand with stack, then only we will understand. Okay. See what is happening here in the sense. Let us take this tree itself. Initially, PTR is pointing to the root node. What is the root node? Plus. Okay. Initially, PTR is pointing to plus. Okay. So plus is a node. It has some address. It is pointing to that address. Okay. So plus is a node. It has some address. Say 1000. It is pointing to that particular address. So after coming in, you are checking whether PTR is not null. If PTR means basically you are checking whether PTR is not null. Yes, PTR is not null, it is pointing to plus. Then what you are doing, again you are calling another time you are calling in order PTR arrow left. So this is called as recursion, a function that calls itself. But as you know, whenever you call a function, what will happen? The return address will be pushed into stack. Whenever you call a function, the return address will be pushed into stack. Okay, so and also the other required data will be pushed into the stack. Okay, so let us assume this is the stack. Okay, say that this is the address, next address to be executed. Say the next address is 2000. Okay, so 2000 will be pushed into the stack in the bottommost position. Okay, and at this point of time where PTR is pointing, PTR is pointing to plus. That information also will be pushed into stack. Return address is 2000, and at this point of time PTR is pointing to where? PTR is pointing to X. Assume this is a pointer. Okay. PTR is pointing to plus. This will be pushed into stack. Okay, before calling. Now you are calling PTR arrow left child. What is the left of plus? Star. With star again you are calling. So now again this function is called. Now where PTR is pointing? Now PTR is not pointing to plus, rather it is pointing to star. Getting? Rather it is pointing to star. Again control comes in and checks. Is PTR not equal to null? Yes, not equal to null. It is pointing to star. So once again it is going to call in order with current PTR's left. What is current PTR? Star. What is its left? Again there is another star. Okay. So before calling that, once again this should be pushed. Once again this should be pushed. This current PTR should be pushed. So what is the return address? Again return address is same 2000. But at this point what is PTR? Where PTR is pointing? At this point PTR is pointing to star. At this point PTR is pointing to star. So this info will be pushed. Okay. After that this will be executed in order ptr arrow left. Okay, ptr is star, its left is also star, so its left is actually pointing to star. So with that again ptr will be called. Again ptr is pointing to star, but it's another star. Again control comes in, checks whether ptr not null. Yes, it's not null, it is pointing to star. Okay, it's pointing to star. So once again what happens, once again you want to call in order ptr arrow left child. Now what is ptr's left child? Now ptr's left child is slash, but before calling this should be pushed, current ptr should be pushed. So again return address is what, 2000, and what is the current ptr? Current ptr is once again ptr, at this point also ptr is pointing to star. At this point also ptr is pointing to star. So this data will be pushed into stack. Okay, so after pushing this, now again you call ptr arrow left child stars. The second star's left child is what, slash. So with a pointer to slash, okay, it's a pointer with a pointer to slash, again in order is called. Okay, now ptr is pointing to where? Now ptr is pointing to the memory location which contains the slash. Okay, or it points to the node which contains slash. Okay, that is node will have a starting address, right? Now ptr is pointing to the node which is slash. Okay, okay, so yeah, so again you come here and check whether ptr is not null. Yes, ptr is not null. Okay, so once again we want to call ptr arrow left child, but before calling this should be pushed into stack. So again push, what is the return address, 2000. Okay, 2000, and now what is ptr value? Now what is ptr value? I mean, where ptr is pointing? Now ptr is pointing to the node which contains slash. Okay, right, fine. Okay, now you call, now what is the left of slash? Left of slash is a. So now pt, now again in order will be called with a pointer to the node a. So now pointer is pointing to the node a, or the starting address of the node a. Okay, right, again you come here and check whether ptr is not equal to null. Yes, ptr is not equal to null, it's pointing to a. Again you call ptr arrow left child. Before that again push. So now if you push, what will be pushed, 2000, and currently where ptr is pointing? Ptr is pointing to a. At this point of time ptr is pointing to the node a. Okay, node a, fine. Okay, so again you call ptr arrow left child. What is a's left child? Currently ptr is pointing to a. A's left child is what, null. So there is no left for a. Okay, there is no left for a, so actually the left of a is null, so it's null. Okay, right, so now you are calling in order with null. So now ptr is actually pointing to null, nothing is here. Ptr is not pointing anywhere, it's pointing to null. Now you come and check if ptr not equal to null. No, it's equal to null, it's equal to null. If it is equal to null, what will happen? Control will return. Okay, it's a void, so there is an implicit return, so control will return. Where it should return? How the function will know? So whenever the return statement is executed, the content of stack will be popped out. With that only the compiler will know where it should return. Okay, so pop the stack. So this item will be popped out. So it means what? Go to the location 2000. It means control should return where? To the location 2000. And at that time, what is ptr value? After moving to the location 2000, I mean, go to the location 2000, there will be an instruction, execute that instruction, and 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 the ptr value, ptr will be at that instruction, ptr will be pointing to a. Okay, so this information will be popped from the stack. So what is in 2000? Printf percentage d ptr arrow data. Okay, so data is nothing but what? So in our case, this is not an a is a character. Okay, everything is a character. So instead of percentage d, you can assume percentage c. Okay, so what it will display? It will display a, right? So first node we have displayed, right? Then again it goes with this instruction. In order PTR arrow right child. PTR is what? A. Does A has a right child? No, there is no right child. But what is its right child? Null. Its right child is null. Okay. Again you are calling PTR. Okay. So before executing, what will happen? Once again stack should be pushed. What should be pushed? Current PTR value and the return address. Are you getting? Current PTR value and the return address. So now you are going to call in order PTR arrow with null. Okay. So where is the control should return now? This is the last statement of this instruction. Okay. So after for example, after executing this particular statement, uh, where the control should go? After executing this particular statement, where the control should go? Right. So basically, this is a if condition. Okay. So basically, this is a if condition. So after executing this statement, the control should go to the next. Okay. So normally this close bracket. Okay. So let us assume this address as 2000. Okay. 2000 or 2004. Let us assume. So say this is 2004. If this is 2004, say each instruction occupies 4 bytes, then this will be 2008. Okay. So 2008 will be pushed into the stack. Okay. And at this point where before calling this null, at this point where PTR is pointing to A. That is correct. Okay. So now this is the top of the stack, right? Fine. So now again you call PTR with null. Now PTR is null. You come here and check what is PTR. PTR is null. If PTR is null, again return. Again pop. Okay, if you pop, what you will get? This information will come out. Okay, that is go to the next instruction, that is 2008. Okay, 2008. Okay, uh, right. So 2008 again. If you after coming out, okay, after coming out again, if you see there is a return statement. There is a return statement, right? So once again it will pop. So once again it will pop. So now when it pops, what you will get? You will get this 2000 and PTR equal to slash, that you will get. Okay. So after printing a, it will once again say that the next instruction is 2000. So again the control will go here. Now PTR is pointing to slash. So after a, it will display slash. Are you getting? So a is displayed. After that, now it is displaying slash. Okay. After a, it will display slash. Okay. So now this is also popped out. Now this is also popped out. Again, it will execute in order PTR arrow right child. But now what is PTR? Now PTR is pointing to slash. Okay. After as of the recent pop, PTR is pointing to slash. But does slash has a right child? Yes, it has a right child. Okay. So what happens? So what happens again? Again, before calling this, it will be pushed. So now the return statement will be 2008. Okay. So 2008 will be the return. That is, this closing bracket will be the return statement. Okay. After returning where the control should come out. And current PTR value is slash. This information will be pushed. And right of PTR is what? Currently slash right is B. So B will be passed to the function. Okay. So now PTR will be pointing to B. Now PTR will be pointing to B. So again it will come and check is PTR is not equal to null. Yes, PTR is not null. It is B. So then once again this instruction will execute. In order PTR left child. Okay. But before that, what should be done? Before that, what should be done? Before calling again, it should be pushed. Okay. So after executing this instruction should be executed. So once again, this will be pushed 2000, and at this point, what is PTR value? PTR value is B, right? PTR value is B. Okay. ptr value is b, so ptr is pointing to b. Okay, then left child of b is what? Left child of b is null. So with null, once again you call this, right? Now what is ptr? Actually it is null. It is null. There is nothing like that, right? ptr is not pointing anywhere. Again you come and check what is ptr. It is null. If it is null, return. The else is not executing means return. It will execute return. So return means again pop. So if you pop, you will understand where it should go back. Actually compiler will do, but for your understanding I am saying. So it should come back to the address 2000, and at that time ptr value is b, right? So this instruction will execute printf percentage c ptr arrow b. Okay. So already we have discussed, already we have displayed what? A and slash. Already we have displayed A and slash. Now B also will be displayed. You getting? So like this it works, right? So remaining steps you can work out because it is very heavily stacks are involved. Okay. So this is the role of the stack. So stack plays a crucial role to ensure this thing works properly. Okay. So finally it will visit in this order. Okay. We have discussed up to this. You can walk through fully so that you will understand how the stack is playing a role here. Okay. So whenever a function is called, okay, the return address and whatever the at that time whatever the pointer value, these are the local variables. It should be pushed into the stack. Okay, right? And whenever you are returning from the function, it should be popped. So you may ask how long you should pop until stack becomes empty. So when the compiler know that I should pop stopping means until stack becomes empty. Okay, so that is the rule. So this is the logic for in-order traversal, and this is the logic for pre-order traversal. The logic is very simple, but understanding you should go through. Okay, void pre-order, it takes a pointer to a node. Again we check whether pointer is not equal to null. So it is pre-order. So first visit that root node. So first we are printing print ptr arrow data. Then again call pre-order this same function recursively by passing the left child as the argument. Again call the same function by passing the right child as the argument. Okay. So this coding also very simple, but you should understand and do. It's not just a matter of memorizing. Okay. So if you see here, first you call in order, then print, and then in order. Okay. But here, first you print, then you call pre-order, and then you call pre-order with first you call first print, then pre-order with left child, then call pre-order with right child. Similarly for post order, if you see, again it takes an argument tree pointer and ptr. Check whether ptr is not equal to null. First call the function post order with the left child, then call the post order function recursively call the post order function with the right child, then print. Okay. So this is the logic for traversal. Let me show you the C code for that. Yeah. So I have saved the file as btree.c. So, so these are the header files we are using stdio.h and stdlib.h. So here I'm creating the node in like how we have discussed in the last class. This is how the book follows. In that style I'm creating. First, before creating a node itself, I'm creating a user-defined data type which is called as node underscore tree. Basically, it's a pointer. Okay, it's a pointer. So after doing this, so this node underscore tree, what is its type? Its type is type def struct node. Type def. So type def is used to create user-defined data type. It is of and this user-defined data type is of type structure node. What is structure node? What is structure node? It contains two things. It contains a data part and it contains two child. Okay, a left child, a pointer to a left child and a pointer to a right child. Basically, this is a pointer. Node underscore tree is a pointer, but already we have defined here, which already we have defined here. Okay, so actually C allows that. With by the at this place, if you see struct node is not defined, but still we are using that because C allows you to use that even a structure even before defining the structure you can use it, right? Okay. So now Now for node tree is like a data type. Okay. Now we can create variable for node tree. Whatever the variable you create, that will be a pointer to the structure node. So for example, here we have created two variables, L child and right or child, which are of type node tree, but they are also what? But they are nothing but a pointer to the structure node. So we are creating a root node and traverse. Sometimes we may use, so whether we are creating traverse, both are assigned to null. Okay, right. So here is a function called create. Create basically it returns a pointer. It returns a pointer to the one of the node. So node tree is nothing but what? It's a pointer to structure node. Okay, and here we are declaring a variable x, and we are asking the user to enter the data for the node, for the particular node. Okay, if the particular node does not exist, then the user should enter -1. Okay, if there is no such node, then they should enter -1. Okay, then we are scanning that. If x is equal to -1, then we are returning null. Okay, otherwise otherwise we create a node. So we already created a pointer. Node is basically a pointer. It's a variable of type node tree. You know what is node tree? Node tree is a user-defined data type which is a pointer to structure node. Okay. So we are allocating memory for node. Node is equal to node underscore tree malloc size of node underscore tree. Okay. This is similar to how we allocated memory for a linked list the same way. Okay. So instead of directly using struct node star, here we are using node underscore tree, which is a user-defined data type, right? Then we are saying that node arrow data is equal to x. So whatever the data we receive, that is assigned to the data part of the node. Okay. So now you have created a node, its data part is assigned. Then what should be done? Its left child should be created. So we are asking the user to enter the left child of this particular node. Okay. What is the left child of this node? We are asking. Then we are saying node arrow left child is equal to create. Again recursion. Again you are calling the same function recursively. Okay. So again it will go back and it will ask the user to enter the data. So now if there is no left child for that particular node, you have to enter -1. Otherwise enter the node value. Okay, like that it will continue. How long it will continue means as long as you don't enter a -1. So first we are, so if you understand properly, first you should enter all the left child of the node of the tree. Okay, we are not entering in level ordering. First you should enter all the left child of a particular node of particular tree. Okay, till you reach the leaf node. Then after reaching the leaf node, for that particular small level of subtree, you have to enter the value for the right child. Okay, so that way it goes. Okay, so once that is done, then we are asking the user to enter the right child of that particular node. Okay, x. Again you are saying that node arrow right child is equal to create. So again you are calling this recursive function recursively, which will, what do you call, uh, which will once again ask the user to enter the data, and that data will be assigned to that particular node. Okay, again for that node you will ask the left child, so on and so forth. It will work in that way. Okay, then return node. Okay, and here I have written the code for pre-order traversal, whatever we have discussed so far. So pre-order, it takes node underscore tree t, and while if t not equal to null, then print of t arrow data, otherwise pre-order of t arrow left child, no, not otherwise, then pre-order t arrow left child, then t arrow right child. Similarly for in order, the same code. Okay, first in order of left child, then print, then in order of right child. Similarly for post order, first post order of left child, then post order of right child of t, then print. Okay, this is the main function. Here we are just saying root is equal to create. That's all. The create function we are calling. So finally the root node will be returned. The address of the root node will be returned by the create function. It returns node, right? It's a recursive call, so there will be multiple return stack will be heavily used. But at last, what will be returned means the root node will be, the address of the root node will be returned, and that will be stored in this pointer root. Okay. Then we traverse the tree in order, so we call the in order function by pausing root. Then we traverse the tree in pre-order, and for that we are calling pre-order with root. Then we traverse the tree in post order, for that we are calling post order and we pause root. Okay. So let me execute the code and I will show you. Before that, let us assume which tree we should use. Okay. Say for example, let me say that assume this is the tree which I want to use. Okay, for this tree I want to execute the code. Okay. Right. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Okay. So how we have to enter the values in the sense, if you see the observe the code properly, first all the left node you have to enter. The first node will be 1 obviously. Then the it will itself ask you have to check and enter. The left of 1 is 2. Then left of 2 is 4. Left of 4 is minus 1. Okay. Then it will ask right of 2. Then it will ask right of 4. Right of 4 is also minus 1. Okay. Then right of 2. Right of 2 is 5. Then left of 5 is minus 1. Right of 5 is minus 1. Then right of 1. Right of 1 is 3. Okay. Then left of 3. Left of 3 is, yeah, then left, yes, yes, then left of 3. Yes, then left of 3 is 6. Okay. Left of 3 is 6. Then left of 6. Is there anything left of 6? No, no left of 6, that is minus 1. Then right of 6, minus 1. Then right of 3, that is 7. Okay, so this is how you will enter, right? Okay, so let me execute the code and I'll show you. So this is a warning, you can ignore that, it's not an issue. So slash b3, enter the data for the root node. Okay, root node is 1. Okay, so if you recall this diagram, left of 1, the left child of 1 is 2. Left child of 1 is 2. Then it will ask left child of 2. Left child of 2 is 4. Then left child of 4, there is no left child of 4, that is minus 1. Then it will ask the right child of 4, that is also minus 1, there is no right child, 4 is the leaf node. Then it will ask the right child of 2. Right child of 2 is 5. Okay, then it will ask the left child of 5, there is no left child, minus 1. Right child of 5, no right child, minus 1. Then it will ask the right child of 1. Right child of 1 is 3. Okay. Then it will ask the left child of 3. Left child of 3 is 6. Then it will ask the left child of 6. There is no left child, minus 1. Then it will ask right child of 6. There is no right child, minus 1. Then it will ask right child of 3. Right child of 3 is 7. Okay. So then it will ask left child of 7 minus 1. Then right child of 7 minus 1. That's it. Okay. This is the traversal ordering for in order, pre order, and post order. that you can traverse and check, right? Fine, let us stop here. Thank you.